And thank you so much for attending our Safety Connection on respiratory protection in the workplace, Ontario Provincial Focus. My name is Jessica Major, and I will be your co-presenter along with Madison Seeloff for our virtual session today. Maddie and I are so appreciative of having you on this call today, so thank you again for joining us. We have a lot to cover, so let's get started. So first, let me take you through some webinar housekeeping. Just a suggestion, please mute other devices and apps to avoid distractions. And please note that your audio line, the speaking side, will remain muted throughout the session, and you will not have the ability to turn your camera on. Today's session will be recorded. It requires some work to take this recorded session and get it posted, so please be patient. And we do not provide a copy of this presentation, but attendees will get a follow-up email. And the email will include some additional resources and references. The conversation or chat feature may be used at times, and it is public. It may be used to enter your response to questions by myself or Maddie, raise questions to the co-presenters, and communicate with other attendees. You can send in your questions as you think of them during the presentation. We will also have a Q&A period at the end of this presentation. You will have the option to focus on content or presentation with the full screen mode. The full screen option is available in the More Actions menu, which is represented by three dots, as shown in the featured image, and then select Enter Full Screen. To get the full screen view during the presentation, you can adjust your view of the content by using View menu, then select More Actions on the drop-down, and then entering full screen. We'd like to make the session as interactive as possible for you, and we will have several polling questions throughout the webinar. These are all multiple choice. The polls may appear in the chat or the pop-up on your screen. You can choose your answer and then select the Submit button. You may have to close the poll as well if it pops up on your screen. And now it is my pleasure to introduce you to my co-presenter, Madison Seeloff. So Madison has a master's degree in public health, specializing in environmental and occupational health from the University of Toronto, and is a certified industrial hygienist, or CIH, with the Board for Global EHS Credentialing, and a registered occupational hygienist, or ROH, with the Canadian Registration Board of Occupational Hygienists. Madison has been working as an occupational hygienist since 2018 and has delivered various hygiene consulting services across Ontario. She's helped support workplaces with their respiratory protection needs, including quantitative and qualitative fit testing, training, and respiratory protection program development. At WSPS, Madison is a specialized consultant in occupational hygiene, providing technical support to Ontario workplaces in Central Ontario.
Thank you, Jessica. And now it's my pleasure to introduce Jess to you all. Jessica is a certified industrial hygienist, CIH, with a board for global EHS credentialing. Jessica has worked in the health and safety field since 2013. She has worked in the manufacturing sector and has provided occupational health, safety, hygiene consulting services for various workplaces under Canadian federal, provincial, and municipal jurisdictions, not limited to government, utilities, construction, manufacturing, services, healthcare, pharmaceuticals, education, and office places in various provinces and territories throughout Canada. At WSPS, Jessica is a specialized consultant in occupational hygiene and provides technical services on behalf of the occupational hygiene practice for the North and East regions of Ontario.
Great. Thanks so much, Maddie, for the great introduction. Okay, so this presentation is copyright protected. Some content in this presentation is from a specific CSA respiratory protection related standard. We've obtained permission to use the CSA content from CSA directly, and CSA has requested that we include this copyright protection information that you see on the screen. So what are our objectives of this webinar? This webinar provides an opportunity to attend from your personal workspace. We are going to share some Ontario regulatory content related to respiratory protection, but also some best practices. And hopefully you hear some information which is of value to you. For Ontario legal requirements, we are going to cover content in the Ontario Occupational Health and Safety Act, Ontario Regulation 833 or O.Reg. 833, and Ontario Regulation 490 or O.Reg. 490. We're not 100% sure of your uses of respiratory protection and the reasons employees are wearing respiratory protection at your sites, but these two regulations might lead you to using respiratory protection. We're going to touch on select parts of the Canadian Standards Association or CSA standard Z94.4 Selection, Use, and Care of Respirators, the most current or 2018 version, which was reaffirmed in 2023. It is 66 pages before the appendices or annexes, and including all of the annexes, it is 163 pages long. Obviously, we cannot cover it all. We might mention another CSA respiratory protection related standard as well. Respiratory protection program, you might have a health and safety manual at your site that includes respiratory protection information, or you might have written measures and procedures about respiratory protection use, or you might have a comprehensive respiratory protection program. We'll discuss the regulatory requirement around these and include some best practices. As part of your respiratory protection program, you might have specific content around hazard assessment, respirator selection, use and care, training and fit testing, and health surveillance. We'll cover the regulatory requirements associated with these topics and include those best practices. In terms of record keeping, how long should I keep records of the above? We will cover this as well. And program evaluation, should an annual review be part of your respiratory protection program? So here's our first poll. For poll question number 1, what industry do you work in? It may be agriculture, for example, livestock, field crops, fruit and vegetable farms, greenhouses. It could be manufacturing. Examples are steel, glass, plastic processing, service, for example, hospitality, retail, food service, or it could be any other industry. So thank you for your participation. I can see the responses rolling in here. So we have majority so far, manufacturing and industrial. We have other as well, which is next in line. But certainly respiratory protection could be used in many different workplaces. So we want to make sure that we're aligning with what the regulations say and what is ideally in the CSA standard as well. So thank you everyone for that. Manufacturing, it is very broad. So if you work in an industrial type workplace, you may very well put yourself in this category outright. If your answer is other, you are welcome to put some information in the chat about what your industry scenario is. So thank you again, everyone, for your participation in this poll. We're following with poll question number 2, our second poll. We're trying to gauge your use of respiratory protection. So does your organization use respiratory protection every day in many places, every day at least in some places, sometimes in some places, or not at all? So I can see so far a majority is every day, at least in some places, sometimes in some places. So there is use at the workplace. And we, again, want to make sure that we're aligning with what the regulations say, as well as ideally what is in that CSA standard. So thank you, everyone who participated in this poll. So looking at legal requirements, as I mentioned in the agenda slide, we're going to cover content in the Ontario Occupational Health and Safety Act, Ontario Regulation 833, which is the control of exposure to biological or chemical agents, and Ontario Regulation 490, designated substances. I might use the term Green Book to cover all of the above collectively. An example of a recent WSPS branded green book, it's shown on the right hand side here on the slide. The cover of the 2024 version looks bit different now. However, you'll still be able to find all that essential regulatory information for your workplace. One question you might have is, why should I have a respiratory protection program or RPP? In general, if your business is in Ontario and subject to Ontario provincial regulations, the Ontario Occupational Health and Safety Act applies to your business. This applies to small and large businesses in many sectors. You might be subject to Canadian federal health and safety legislation, and perhaps not subject to the Ontario Occupational Health and Safety Act. However, certainly there are a lot of elements here in this presentation that may apply. If you look at the Ontario Occupational Health and Safety Act under duties of employer in section 25(2)(h), you will see an employer shall take every precaution reasonable in the circumstances for the protection of the worker. So you might know this as the due diligence clause. This is very general in nature and applies to many aspects of health and safety, including respiratory protection. So many Ontario regulations refer to respiratory protection. The regulation shown in this slide, O.Reg.833, it applies to most industrial type workplaces, as in the manufacturing sector. You might be in the mining sector and different regulations would apply. The main focus today will be both Ontario Regulation 833, so that regulation that deals with the recognition, evaluation, and control of exposure to airborne chemicals. Respiratory protection is referenced considerably in this regulation. Then we have Ontario Regulation 490. So a regulation that deals with the regulation, evaluation, and control of exposure to a specific group of chemicals or compounds called designated substances. So there are 11 chemicals in this regulation, Ontario Regulation 490, that apply. And some common ones are crystalline silica, lead, isocyanates, asbestos. Respiratory protection is referenced as well considerably in this regulation. And there is some additional content that O.Reg. 833 does not have around respiratory protection. There are definitely parts of Ontario Regulation 851, industrial establishments, that also touches on personal protective equipment, including respiratory protection. There are definitely parts of Ontario Regulation 278, designated substances, asbestos on construction projects and in buildings and repair operations, that also touches on PPE, including respiratory protection. So we won't focus so much on these. It would be more so Ontario Regulation 833 and 490. So in Ontario Regulation 833, before Section 9, you see in the title Respiratory Protection Program. So this title, it applies to all of Sections 9 to 13. So Sections 9 to 13 of O.Reg. 833, they are relatively new. This content was not present in the 2019 Green Book, for example. These sections were added in 2020. So there are many employer duties related to respiratory protection. In Section 9, subsection 1, it states an employer who provides a worker with a respirator shall ensure that the respirator is appropriate in the circumstances for the form and concentration of an airborne biological or chemical agent in respect of which the respirator is to be used. As an example, if you're working with a chemical, let's say ammonia, at a certain concentration, the respiratory protection should protect you against ammonia at that concentration. An employer who provides a worker with a respirator shall ensure that the respirator meets or exceeds the requirements set out in this section and sections 10 to 13. And an employer who provides a worker with a respirator shall ensure that that respirator is used by workers in accordance with the requirements of this section and sections 10 to 13 of the regulation. So under section 9, subsection 2, we've yellow highlighted the content. And an employer who provides a worker with a respirator shall establish written measures and procedures regarding the selection, care, and use of respirators. So these written measures and procedures, these might be part of your respiratory protection program. So in part 3 of section 9, you can see an employer who provides a worker with a respirator shall provide training and instruction to the worker in the care and use of the respirator before the worker first uses the respirator. So before. There's more detail in section 9 around the specifics of the training. In section 10, under respirator requirements, it indicates a respirator must meet the following requirements. It must be approved by NIOSH or approved by a testing and certification agency other than NIOSH, and in the opinion of a person qualified because the knowledge, training, and experience in industrial hygiene practice afford the worker using the protection at least equal to the protection afforded by the use of a respirator approved by NIOSH. So you may have seen many respirators out there that are NIOSH approved. NIOSH means the National Institute for Occupational Safety and Health. It is based in the US. NIOSH is defined in Section 1 of Ontario Regulation 833. So my whole career in health and safety and hygiene, I have used mostly, perhaps only NIOSH approved respiratory protection. On the right-hand side of the slide, you can see the image of the respirator approval program at NIOSH. So this is taken directly from the NIOSH site. When the COVID-19 pandemic hit in calendar year 2020, eventually there were shortages of respiratory protection. So global agencies in Europe and Asia that also approved respiratory protection were becoming more apparent. Still, I'm not aware of enough, based on my knowledge, training, and experience in industrial hygiene of these other agencies, to say that they are or are not equivalent to NIOSH. There is another CSA standard, Z94.4.1, which was brought out in 2021, called Performance of Filtering Respirators. So this is the first edition of the standard, and it provides performance requirements for filtering respirators for use in Canada. So the impact of the COVID-19 pandemic demonstrated the need for a domestic supply of filtering respirators such as N95 respirators that would meet required performance and quality requirements to protect Canadians. The CSA group collaboratively worked with key stakeholders, including Health Canada, the Public Health Agency of Canada, the National Research Council, and academia to address this need for a new national standard of Canada that would specify performance and testing requirements for filtering type respirators. You may be interested in keeping posted on this standard as it is relatively new, and it's still being translated to manufacturers to make those Canadian certified respirators. So back to Ontario Regulation 833 or O.Reg.833. In Section 10, subsection 2, it indicates that the respirator must meet or exceed the applicable assigned protection factor set out in Schedule 2 in the regulation. We will touch on this more later. In Section 1 of O.Reg. 833, we see a definition for assigned protection factor or APF. So an assigned protection factor means the anticipated level of respiratory protection that would be provided by a properly functioning respirator or class of respirators to properly fitted and trained users. So different respirators provide different degrees of protection. This is very important to remember. So more on section 10, starting in section 10 subsection 2. So an employer who provides a worker with a respirator shall have regard to the following when selecting the respirator: the airborne concentration of the biological or chemical agent to which the worker is exposed, calculated in accordance with Schedule 1, and the maximum use concentration of that respirator. As an example, if a worker is exposed to the Ontario occupational exposure limit, is the respiratory protection they're using enough to provide the protection needed? There are methods and tools to evaluate this, and we'll get into this in future slides. Number 2, the manufacturer's information on the intended use, scope, and limitations of the respirator. So one example, some respirators purify the air. If the work environment has an oxygen concentration of less than 19.5%, then using respiratory protection that just purifies the air is not the right solution. And number three, the potential for an atmosphere with an oxygen concentration of less than 19.5%, an IDLH atmosphere, or oil in the atmosphere. So IDLH atmosphere. In case this term isn't familiar, it is defined in O.Reg. 833, Section 1. IDLH atmosphere means an atmosphere that poses an immediate threat to life or that will cause irreversible adverse health effects or impair a worker's ability to escape from the environment. There are a few locations where you can find information on IDLH associated with a given chemical. Safety data sheets may have information on IDLH. The NIOSH Pocket Guide also has this info on IDLH for a given chemical, and the Pocket Guide is found on the NIOSH website. Oil atmosphere. Why does this matter? Some classes of respiratory protection filters are made for oil environments and some are not. For example, if I worked in a car dealership, mechanic shop doing oil changes, or worked in a place that provides oil based rust proofing, I would need a respirator and the associated filters to be suitable in an environment with airborne levels of oil present. We'll hear more on this later. Section 11. Section 11 is titled Requirements, Use of Respirator. So in Section 11, subsection 1, a respirator shall be used in accordance with the manufacturer's instructions. When you buy respiratory protection, the external packaging and/or internal documents inside the packaging will have a fair bit of information from each manufacturer on the use of that specific respiratory protection. It is always good to read the manual. So manufacturers' websites have plenty of information as well, and most manufacturers have 1-800 helplines available to you as well. In subsection 2, a worker shall not be assigned to an operation that requires the use of a respirator unless the worker is physically able to perform the operation while using the respirator. So there might be more than one way to interpret this information. Is this talking about user health screening? This might be one interpretation. So user health screening is important to ensure that the worker is fit to wear a given respiratory protection. So wearing respiratory protection, it puts some additional demand on your respiratory system. For most, it's not an issue. But now imagine a worker who might be asthmatic. The additional demand that that respiratory protection places on the respiratory system should be evaluated with a medical practitioner. A portion of a WSPS user health screening tool is shown on the slide here. We're going to talk about this a little more in future slides. Um, so another way to interpret this information, is this talking about just being able to wear and use the respiratory protection in the workplace from a practical perspective? For some who use airline type respiratory protection, it might be tricky to move around a workplace with the airline getting caught up on objects at the site. This might be another interpretation. Section 12 is titled Requirements, Tight Fitting Respirator. So in Section 1 of Ontario Regulation 833, tight fitting means designed to form a complete seal with the user's face or neck. So this applies to most respiratory protections, such as disposable type filtering face piece respiratory protection, example N95s, half face and full face respiratory protection, but not all available respiratory protection is tight fitting. In Section 12, subsection 1, a respirator that is designed to be tight fitting shall be tested for fit in accordance with one of the following: a qualitative fit test or a quantitative fit test. So these fit tests are defined in Section 1. A qualitative fit test means a qualitative fit test method set out in Annex B of CSA Standards Z94.4, that selection, use, and care of respirators, or go-to to know about respirators at your workplace. You might ask, can I get access to this CSA respiratory protection standard? Um, I use select CSA standards all the time. My employer has a subscription for accessing CSA standards. Your employer can do the same. But select CSA standards can be viewed online for free. So this is one that can be viewed for free, at least according to one of my colleagues who spoke with CSA recently. But you may need to have a username and a password for this. Other wording I might use for a qualitative fit testing method. So qualitative fit testing is a pass-fail method that uses your sense of taste or smell or your reaction to an irritant in order to detect leakage into the respirator face piece. Qualitative fit testing does not measure the actual amount of leakage. And then there's quantitative fit testing, which means a quantitative fit test method set out in Annex C of that CSA standard Z94.4. Other wording I might use, a quantitative fit test or QNFT can be used to fit test any tight fitting respirator. It involves an instrument to measure leakage around the face seal and produces a numerical result called a fit factor. A respirator's assigned protection factor is only valid if the respirator fits correctly. So we'll have more on this in future slides. So more on section 12. In subsection 2, a worker shall conduct positive and negative pressure user seal checks prior to every use of a tight-fitting elastomeric respirator. So a seal check, it evaluates how well your respiratory protection you're wearing fits at the moment. It's an action conducted by the respirator user to determine if the respirator is properly seated to the face. So that seal check, it is not a fit test. It determines what the respirator is fitting like at the moment. So we'll have more on this in future slides, but I do want to touch on the term elastomeric. So this term is not defined in section 1 of the regulation. It's a term used in respiratory protection industry and beyond as well. Many manufacturers use this term when describing the rubber-like properties of the part of the face piece, the half face or full face part of it that seals with the face. You might say that elastomeric is similar to being flexible or pliable. So the material in that respiratory protection can regain its original shape after being stretched. In subsection 3, a respirator that is designed to be tight fitting shall not be provided to or used by a worker with facial hair that comes between the sealing surface of the face piece and the face or that interferes with the functioning of the respirator. So a worker is required to be clean shaven when wearing respiratory protection, not just at the time they're fit tested, but also every time they wear it. And this is based on the fact that human hair is much larger in diameter than many airborne contaminants. So if that facial hair infringes on the sealing surface of the respirator, then the airborne contaminants can get through. The CSA standard on respiratory protection Z94.4, it digs more deeply into this issue. So it has more descriptions in the body of the standard and photos and descriptions in one specific annex as well. Section 13 is titled Requirements, Care and Maintenance of Respirator. So in this section, a respirator shall be cared for and maintained in accordance with the manufacturer's instructions. Cared for and maintained. So can it be cleaned? Some respiratory protection like N95 filtering face pieces cannot be cleaned. They are considered disposable. If the type of respiratory protection can be cleaned, how? Will alcohol-based wipes be okay? For at least some manufacturers, it is no. So what about storage between use? There are all kinds of ways to store it, from sealed totes to bags with drawstrings to sealed bags. When looking at section 13, didn't we already have some wording that was similar? We did in section 11. So requirements, use of the respirator in section 11, subsection 1, a respirator shall be used in accordance with the manufacturer's instructions. What is the difference between use and cared for and maintained? The yellow highlighting shows the use. So what needs to happen before I wear it, the fit tests and when I just put it on, those seal checks. Also, I need to be clean shaven when wearing tight fitting respiratory protection. So some perspective. Not being clean shaven is by far one of the most common non-compliance observations for users of respiratory protection that I've seen in workplaces where respiratory protection is used. The other is around midday storage. So what do I mean by this? The employee has brought respiratory protection from their locker into the work area. They use the respiratory protection for a while, but now they don't need it. Do they go back to their locker and put it away? Not usually. So I do see the respiratory protection on work surfaces that might not be the best fit, like dirty countertops or tables with other dirty equipment. It would be best to have it stored back in your bag or tote if it is not being used. So you may have designated substances at your site. So as previously mentioned, some common examples are lead, crystalline silica, and isocyanates. But on top of those three, the full list includes acrylonitrile, arsenic, asbestos, benzene, coke oven emissions, ethylene oxide, mercury, and vinyl chloride. O.Reg.490 has all the same respiratory protection content above. Although the numbering of the sections are not 9 through 13, they are all in section 26, numbered from 26.1 to 26.5. There are some differences between O.Reg.833 and O.Reg.490 outside these sections which relate to respiratory protection. O.Reg.490 does have content that O.Reg.833 does not have. This will come up in the next few slides. So we've discussed a respiratory protection program. How about this question? When do I need a respiratory protection program? A very general answer: when an employer provides workers with respiratory protection from Section 9, the employer needs a respiratory protection program, at least written measures and procedures. When should an employer provide respiratory protection to an employee, or why might an employer provide employees with respiratory protection? So another general answer: workers are exposed over the Ontario Occupational Exposure Limit, or OEL, for any given chemical, or said slightly differently, over 100% of that OEL. What about this scenario? You're approaching the Ontario OEL. Imagine you're between 50 and 100% of the OEL. An employer might make a conservative action to provide respiratory protection. What if you do not know the exposure level? An employer might make a conservative action to provide that respiratory protection. So protect first, measure second. Designated substances. You can see a snip on the right-hand side. The yellow highlighting, there's a specific regulatory requirement that is not present in Ontario Regulation 833. So in O.Reg. 490, Section 18, subsection 2, a worker who is exposed to any level of an airborne designated substance may request a respirator from his or her employer, and the employer shall provide a respirator in response to the request. What about a worker brings in their own respiratory protection in cases where the employer is not providing respiratory protection for the work involved? So this is often a great question that is presented. O.Regs 833 and 490, they don't appear to specifically address this. And I cannot speak for the Ministry of Labor, Immigration, Training and Skills Development inspector and how they might respond. But imagine an MLITSD inspector comes on site and they see a worker wearing respiratory protection. They might ask, are they trained on the use of respiratory protection? Are they fit tested? The employer might counter with, this employee brought in the respiratory protection on their own. And there could be a fair bit of discussion from this point. Is there a reason that the employee is choosing to wear the respiratory protection? Is there evidence that respiratory protection is or is not needed based on occupational hygiene exposure monitoring? Let's just say this point on the slide and the speaker notes around it create a fair bit of discussion internally. So you may need to confer with the Ministry of Labor, Immigration, Training and Skills Development if workers bring in respiratory protection on their own. Also, if the employer is providing respiratory protection and the employee chooses to bring some alternate respiratory protection, that protection brought in by the employee must still meet the employer's requirements. So you've probably heard the expression, as I mentioned before, PPE or personal protective equipment. This is a last resort. Respiratory protection, it is a type of PPE. So you will even find this mentioned in a Ministry of Labor training, immigration training and skills development guide, a guide to designated substances in the workplace. Let's see how O.Reg. 833 addresses this. So for Section 3, subsection 1, every employer shall take all measures reasonably necessary in the circumstances to protect workers from exposure to a hazardous biological or chemical agent because of the storage, handling, processing, or use of such an agent in the workplace. Then we have subsection 2. The measures to be taken shall include the provision and use of substitution of the hazardous biological or chemical agent, engineering controls, administrative controls, including work practices, hygiene facilities and practices, and, if Section 7.2 applies, personal protective equipment. The measures to be taken, like substitution, engineering controls, administrative controls, all of these collectively might be known to you as the hierarchy of controls. So let's take a closer look at Section 7.2 on the next slide. Employer provided respiratory protection, but still as a last resort. So Section 7.2, subsection 1, an employer shall protect workers from exposure to a hazardous biological or chemical agent without requiring them to wear and use a respirator, unless subsection 2 applies or the employer complies with an applicable code of practice. We're going to get to Section 7.2, subsection 2 in the next slide. First, what do they mean by an applicable code of practice? Codes of practice are referenced in section 2.1 of O.Reg. 833. So codes of practice relating to the exposure of workers to biological or chemical agents that have been approved by the minister for the purposes of subsection 32.2, subsection 1 of the Act are available on the Ministry's or the Government of Ontario's website. So historically, the respiratory protection codes in O.Reg.490 were present in older versions of the Green Book. These respiratory protection codes no longer exist in the current Green Book. The respiratory protection codes indicated specific types of respiratory protection when working with specific designated substances. There is a code for medical surveillance referenced in O.Reg. 490, Section 1, which is an example of a code of practice, but this is not a code for respiratory protection. As a side note, there is also an auto body shop isocyanate control program checklist, which includes applicable respiratory protection for worker safety. And this was developed by the Ministry of Labor Immigration Training and Skills Development. It is a useful tool your auto body shops can use to learn how to protect workers from exposure to isocyanates that may cause serious health effects or occupational illness. And this checklist, it can be adapted to other isocyanate related applications as well. And you can find it online through an online internet search. Now let's see section 7.2, subsection 2. The employer shall provide and workers shall wear and use a respirator appropriate in the circumstances to protect workers from exposure to the agent. A, if substitution of the agent is not reasonable or practical, and B, if engineering controls required by this regulation are not in existence or are not obtainable, are not reasonable or not practical to adopt, install, or provide because of the duration or frequency of the exposures, or because of the nature of the process, operation, or work, are rendered ineffective because of a temporary breakdown of the controls, or are ineffective to prevent, control, or limit exposure because of an emergency. The emphasis in this regulation is to substitute where practical or reasonable. I've definitely seen operations where leaded solder is used, for example. My first question always, thinking like an occupational hygienist, is why can't they go to non-leaded solder, like a tin silver or tin copper combination? Usually the answer I hear is that this is what our customers are asking for, and we need to deliver or they'll just go somewhere else. Substitution doesn't always work. I see the wording around engineering controls. If a worker can wear respiratory protections, if engineering controls are not in existence or not obtainable, I will say I do go to workplaces where they don't have engineering controls, but I'm usually convinced that engineering controls do exist for the application. Or I've been to other businesses like theirs and seen engineering controls that might be quite suitable. For Section 7.2, subsection 3, an employer who provides a worker with a respirator shall comply with the requirements set out in Sections 9 to 13 of this regulation. I know we're just getting started, but I'm going to offer a bit of a recap here. So, a summary of the Ontario regulatory content when looking at respiratory protection. First, implement the hierarchy of controls. You may use different wording or you may break this down into specific steps like elimination, substitution, engineering controls, work practices, and procedures. Respiratory protection as a last resort or only in select scenarios. If respiratory protection is in use or provided, then many regulatory requirements apply, such as the user health screening, fit testing, seal checks before use, using a NIOSH approved respirator or respirator approved by another testing and certification agency. There are many possible reasons why employers provide respirators, including but not limited to exposure over 100% of that Ontario occupational exposure limit. So you can see those in O.Reg.'s 833 and 490. And just a bit more info for you, if you do an internet search online for current occupational exposure limits in Ontario, there is an extended list which contains more regulatory exposure limits that may not be available in the table in O.Reg. 833. So just take note of that and take a look at what you're using at your workplace and check it with that extended list. Um, the employer could argue that they have not met the duty to protect. Um, let's say the exposure is over 50%, but under 100% of the Ontario occupational exposure limit. The employer could argue that they're not certain they've met the duty to protect. In Ontario Regulation 490, designated substances, Section 18, the worker may just ask for respiratory protection and it must be provided. There may be a situation where the exposure is unknown or not measured, and the employer could argue that they're not certain that they've met the duty to protect. Or the employer sees a potential for future lower occupational exposure limits like manganese or silica in Ontario. Maybe the employer sees an exposure limit from an organization that the Ministry of Labor, Immigration, Training, and Skills Development aligns with considerably. Um, if a worker brings in their own respiratory protection because they're more conservative than their employer wants to be, then be aware that others, including the Ministry of Labor, Immigration, Training, and Skills Development, might have questions about the use of that respiratory protection. So let's go on to our next poll question for today. Does your organization have a documented respiratory protection program? So we have option A, yes, we have a documented respiratory protection program. B, no, we don't have a documented respiratory protection program, but have some written procedures and use respiratory protection. We have C, no, we don't have a documented program and no written procedures, but use and or provide respiratory protection. And D, we're not sure. So I see some responses that have rolled in. So for the most part, we have a yes, there is an RPP in place. Excellent. That's what you would need. That's what you would want. And of course, you would want to make sure that you're reviewing your program to make sure that it is relevant, it is current. Um, if you do have written procedures, or those written measures and procedures for the use of respiratory protection, that is great to have. Make sure that you do have all the elements you need as per the regulation, O Regulation 833. Um, No, and no written procedures, but use and provide respiratory protection. I see a small percentage there and not sure. So certainly you do want to make sure that you have those written measures and procedures in place. So take a look at Ontario Regulation 833 or 490 if they apply, and just make sure that you have those elements in place to make sure, one, that your workers are protected, and two, that you are in compliance with the regulations. So thank you so much, everyone, for your responses. So I'm going to start sharing information from the respiratory protection focused CSA standard Z94.4. So I'll start with who or what is the CSA? So the CSA is the Canadian Standards Association. It's accredited by the Standards Council of Canada. It's a not-for-profit, non-statutory, voluntary membership association engaged in standards development and certification activities. So this CSA group standards, they reflect a national consensus of producers and users, including manufacturers, consumers, retailers, unions, professional organizations, and governmental agencies. Typically, there's a project manager involved who partners with volunteers of producers and users forming that committee. The committee has a chair, maybe one or more vice chairs and members that are voting and non-voting. The most well-known respiratory protection focused CSA standard, that is the Z94.4. The most recent version was 2018, which was actually reaffirmed in 2023. They can be reaffirmed from time to time. They're also revised from time to time, but often you'll see that CSA standard said 94.4-18 and in brackets R 2023 to show that it's been looked at and reaffirmed just last year. So how does that CSA standard dovetail with the Ontario regulations? So in Ontario Regulation 833 Section 1, the two types of fit tests, quantitative and qualitative, they reference the CSA RP standard. So for that qualitative fit test, it says that method set out in Annex B of that CSA standard Z94.4, and same with quantitative fit test. You can find that method set out in Annex C of CSA Z94.4-2018. So the CSA standard, the SED 94.4, it gives considerable guidance, detail, and information to support the implementation of the Ontario regulations specific to respiratory protection. So you might call this a best practice. So I'm taking content from the preface. The CSA Z94.4 Respiratory Protection Focus Standard sets out requirements for the selection, use, and care of respirators and administration of an effective respiratory protection program in the workplace. So on the right-hand side, you'll see a cover of the CSA Standard Z94.4. So the respiratory protection program or RPP components listed are taken from the table of contents. So using CSA terminology, what you might call chapters in a book or reference text are called clauses in this standard. These components are all part of a comprehensive RPP, so roles and responsibilities, hazard assessment, respirator selection, training, respirator fit testing, use, care, maintenance of the respirators, health surveillance, program evaluation, and record keeping. Um, the program evaluation and record keeping components, these are not specifically mentioned in those Ontario regulations 833 or 490. And some of the clauses have specific content that is not addressed in these regulations. So, for example, how often should I fit test? And are there any circumstances where an employer should fit test an employee again, even though they fit tested them a few months ago? So, here's an example where I might fit test again. When there are significant changes to the user's physical conditions, such as significant weight gain or loss, this would be a fair reason to fit test employees again. So one of the CSA clauses, clause 6, titled Hazard and Risk Assessment. So hazard assessment is required in Ontario Regulations 833 and 490. So in Regulation 833, Section 9, an employer who provides a worker with a respirator shall ensure that the respirator is appropriate in the circumstances for the form and concentration of airborne biological or chemical agents in respect of which the respirator is to be used. So the employer must do a hazard assessment of the chemicals and or biological agents in the workplace to make a determination of the type of respiratory protection they're going to use. I might have gases, vapors, dusts, fumes, mist, smoke, or fibers. I might have the potential for oxygen deficiency. For operations with a lot of solvents in tanks, vats, or vessels, you may have nitrogen inerting on your site. This nitrogen inerting process needs to be managed. What if there's too much nitrogen? Could it displace the oxygen in the work environment? In the CSA standard, there is additional content on evaluating the potential for oxygen deficiency. So one example, if there is a potential for that oxygen deficiency, the level of oxygen should be measured. We've already touched on IDLH, so you can look at the safety data sheets, the NIOSH Pocket Guide, or many other reference texts for information on the IDLH level. Another consideration is if the chemical can be absorbed through or is irritating to the skin or eyes. So this would impact the hazard assessment. You might consider full face respiratory protection, which provides eye protection in addition to protection for your lungs. So, poll question number 4. Does your organization conduct occupational hygiene exposure monitoring or assessments? We have yes, no, or not sure. So, I might be a bit biased here as an occupational hygienist. I am very pro exposure monitoring. Some organizations may be very formal about it with a specific schedule, specific work areas and tasks, types of monitoring, and minimum number of samples. Others do it from time to time less formally. Others may do it as a response to worker complaints only or when ordered to do so by a regulatory authority like the Ministry of Labor, Immigration Training, and Skills Development. So I can see here we have about half saying yes. Hygiene exposure monitoring assessments are conducted. So that's really great to hear. For those who responded no or not sure, perhaps may not apply. But if you are using respiratory protection at your workplace or attending this safety connection, certainly you would want to evaluate that your respiratory protection being applied is providing the right degree of protection for what is in the air at your workplace. So thank you everyone for providing responses to that. So now we're at the occupational hygiene exposure monitoring strategy. So for this strategy, most of these questions shown on the slide, you likely want to answer before you go ahead and complete the exposure monitoring. So what chemicals should be involved after looking at the safety data sheets and the work processes involved? Should I use a standard method for workplace air sampling and analysis as mentioned in O.Reg. 833 in section 6? Or should I use a direct reading instrument to determine the airborne concentrations of a chemical agent? Is that instrument manufactured or maintained in accordance with the manufacturer's instructions? So where should I sample? The emphasis is usually for most directly affected employees, but do you need to consider some nearby employees as well? Maybe some area samples in addition to the personal samples. When to sample? Ideally, samples should be representative. So you can see this in O.Reg. 833, Schedule 1, Item 4. Airborne concentrations will vary based on numerous factors such as activities occurring on the day, production rates, products being used, number of workers present in the work area, work practices and procedures followed by the workers, the effectiveness of controls, and environmental conditions on the day of the assessment. For example, bay doors being opened or closed. It's always something I would put in my field notes and include in the report. How long to sample? So we're going to dig into this topic on the next slide. This is based on exposure limits. How many samples? The short answer, enough to be confident that the results of the measured exposure characterizes the exposure well. The last question on the bottom row on the right, it's more of a reflection after you've sampled. Was the measurement exposure normal, less than normal, or more than normal, based on feedback from the workplace parties involved? So let's move on to the Ontario Occupational Exposure Limits, or OELs. Exposure limits, they can be full shift duration, like time-weighted averages, the STEL, short-term exposure limit, or ceiling. You might call these types of exposure limits. So each has a definition in O.Reg.833 and 490 in Section 1. So time-weighted average, or TWA, it means the time-weighted average airborne concentration of a biological or chemical agent to which a worker may be exposed in a work day or work week. The STEL, or short-term exposure limit, it means the maximum airborne concentration of a biological or chemical agent to which the worker may be exposed in any 15-minute period. There are more details around this exposure limit that we really won't get into here. Ceiling limit, or C, it means the maximum airborne concentration of a biological or chemical agent to which a worker may be exposed at any time. So that's why it's the ceiling limit. Shown on the slide is Table 1, Ontario Table of Occupational Exposure Limits. Acrylonitrile, as an example, has both a time-weighted average and a ceiling exposure limit, and even a skin notation. So the skin notation, it means a danger of cutaneous absorption. So at this point, I'm going to pass the baton over to Maddie. So take it away, Maddie.
Thanks, Jessica. Give me 1 sec here. I'll just take control. Good morning, everyone. Okay, so next we're going to talk about respirator selection. As Jessica discussed, respirator requirements are outlined in O.Reg.833, Section 10, and O.Reg.490, Section 26, Subsection 2. These sections outline that respirators be NIOSH approved or approved by an agency other than NIOSH, but that, in the opinion of a qualified person, provides the same or greater protection than a respirator provided by NIOSH. Meets or exceeds an adequate assigned protection factor. And we'll talk about assigned protection factor in a few slides. Are selected based on airborne contaminant concentration and maximum use concentration of respiratory protection. We'll talk more on maximum use concentration as well in a few slides. And selected based on manufacturer's information on the intended use, scope, and limitations of the respirator. Some other factors that need to be evaluated are the potential for an atmosphere with an oxygen concentration less than 19.5% or an oxygen deficient atmosphere and an immediately dangerous to life and health atmosphere. Next, let's look at how we might be able to determine if a filtering face piece respirator is NIOSH approved. So for filtering face piece respirators, there are markings on the outside of the respirator that you can look for to evaluate if it is NIOSH approved. So look for a TC approval number. Would be something like TC84A followed by a few digits for a filtering face piece. You can look for the brand name such as 3M or Moldex. You can look for the NIOSH logo in block letters. You can look at the filter designation, so filter class, filter efficiency. We'll discuss more on filter class and filter efficiency in the coming slides. You can also look for a lot number and a model number. This example covers filtering face piece respirators. If you want to determine if your half face piece respirator is NIOSH approved, consider reviewing the manufacturer's documentation, going online to their website, or going online to NIOSH's certified equipment list. In general, if you purchase respiratory protection from a reputable supplier, then it would be NIOSH approved, but it's important to verify this. Now we're going to cover types of respirators. Here we have a basic categorization adapted from the CSA standard, providing select content only. Starting with air purifying respirators. Air purifying respirators can be powered or non-powered. Non-powered air purifying respirators rely on the user's breathing to draw air in through the air purifying components, while powered air purifying respirators have a battery-powered blower that draws air in through the filter component. Depending on the filter, canister, or cartridge used, these respirators can be gas and vapor removing, gas such as ammonia, or vapor such as toluene using a chemical cartridge, for example, particulate removing using a particulate filter, or gas, vapor, and particulate removing using a combination chemical cartridge and particulate filter. And we can also have multifunctional, which means a configuration incorporating an air purifying respirator and a powered air purifying respirator. So this is a PAPR, a powered air purifying respirator that is approved to operate as a non-powered respirator if the motor fails. These respirators, air purifying respirators, can remove many contaminants from the air, but they can't add oxygen to the air. Air purifying respirators cannot be used in oxygen deficient atmospheres or at immediately dangerous to life and health atmospheres. Next, we'll look at atmosphere supplying respirators. Just as the name suggests, these respirators provide clean breathing air or oxygen to the user. Respirators that fall into this category include self-contained breathing apparatus, SCBA, supplied airline breathing apparatus, SABA, and multifunctional. Multifunctional is a configuration of both SCBA and airline, so it's an airline respirator with an auxiliary self-contained breathing supply. We will cover more on these types of respiratory protection in a bit more detail in the coming slides. However, the primary focus of this safety connection is on air purifying respirators, and we don't go into detail on the use of atmosphere supplying respirators. Next, let's look at types of air purifying respirators. Examples of non-air purifying respirators include filtering facepiece respirators. For filtering facepiece respirators, you'll notice the entire facepiece is the filtering element, which filters particulates as the wearer breathes. We also have elastomeric half facepiece respirator with a cartridge and or a filter. For elastomeric half facepiece, you might notice that the respirator covers the mouth and nose only, leading to its description of half facepiece. These respirators can be used with a variety of different filters and or chemical cartridges. And next we have elastomeric full face piece with a cartridge or a filter. As you can see, the full face piece covers the entire face, including the eyes. There are a variety of reasons why you might use a full face piece respirator, but preventing eye irritation is one of them. Next, we'll look at powered air purifying respirators. Powered air purifying respirators, or PAPRs, have a battery-powered blower that pulls air through attached filters, canisters, or cartridges. They provide protection against gases, vapors, or particles when equipped with the appropriate cartridge, canister, or filter. So we can see in the picture here, we have a worker wearing a PAPR on their hip or their back. Air would be drawn in through the cartridge here, and purified breathing air provided into the worker's hood. Loose-fitting PAPRs do not require fit testing and can be used with facial hair. So a scenario where you might use a loose-fitting PAPR is to accommodate a worker with facial hair. Next, we'll look at airline respirators. Airline respirators provide clean breathing air to the user from an external source, such as fresh outside air provided using an air compressor and a compressed air line. So you can see here, we have a picture with a compressed air line coming in, attaching to the worker's respirator, providing fresh breathing air to the worker's respirator. An example where you might see supplied air respirators used is when spray painting with isocyanates. At an auto body shop, for example, the Ministry of Labor, Immigration, Training and Skills Development has a guide to isocyanates in auto body shops available online. The link will be in our reference list. This guide outlines that workers must wear supplied air while working with isocyanates or when spraying materials containing isocyanates. O.Reg.833 and O.Reg.490 also outline compressed breathing air requirements. If you're using a compressed breathing air system, review these requirements as they cover aspects such as the testing of compressed breathing air and the location of air compressors. We don't go into atmosphere supplying respiratory protection in detail in this safety connection, but if you do use compressed breathing air, make sure you review these requirements. Next, we'll look at self-contained breathing apparatuses, or SCBA. SCBA are used for entry into or escape from environments considered to be immediately dangerous to life and health. They contain their own breathing air supply. You can see here the worker has a supply of breathing air in a cylinder on their back, and the breathing air is provided into the worker's respirator. May be used by first responders, for example, such as firefighters. O.Reg.833 and O.Reg.490 again outline compressed breathing air requirements. We don't go into detail in the safety connection on those requirements, but if you use SCBA, make sure you review these. So now that we've covered some of the different types of respiratory protection available, we'd be interested to know what type of respirators do you use in your workplace? Do you use filtering face piece, half face piece, full face piece, maybe a combination of the above? Maybe it's you're not sure. Atmosphere supplying or you're not sure. Yeah, awesome. I see a few responses coming in, a combination of the above, so different respirators for different tasks, maybe some filtering face piece, some half face piece, some full face piece, and you're not sure, and no atmosphere supplying. So thank you for those responses. Next, we're going to cover assigned protection factor. So O.Reg.833 and O.Reg.490 outline assigned protection factors for different types of respirators. So again, what is assigned protection factor? In general, it's a value indicating the anticipated level of protection that would be provided by a properly functioning and properly fitted respirator to trained users. So it's the anticipated level of protection that a respirator would provide. Let's take a look at different assigned protection factors for the different types of respirators. We can see here different respirators have different assigned protection factors. If we look at a filtering face piece respirator, has an assigned protection factor of 10, along with the half face piece respirator, assigned protection factor of 10. Air purifying full face piece respirator, assigned protection factor of 50. And you'll see that we've highlighted this one, and I'll come back to this one on the next slide. Powered air purifying respirator, the assigned protection factor depends on the configuration, and same with airline respirator, depends on the configuration or mode that it's operated in. If we go all the way down to self-contained breathing apparatus, we can see it has an assigned protection factor of 10,000. So overall, assigned protection factors go from 10 for a filtering face piece all the way to 10,000 for SCBA. We highlighted air purifying full face piece because the assigned protection factor depends on the method of fit testing used according to CSA Z94.4-18, and I'll explain a bit more on the next slide. So following CSA Z94.4-18, Section 9.3.3, qualitative fit testing has only been validated to a fit factor of 100. This means that tight-fitting respirators operated in air purifying negative pressure mode can only be validated to a maximum assigned protection factor of 10. A maximum assigned protection factor of 10 using a qualitative fit test method. So a negative pressure full face piece air purifying respirator validated by a qualitative fit test has a maximum assigned protection factor of 10 and not 50. To get that assigned protection factor of 50, you would need to use quantitative fit testing. And we'll talk a little bit more about qualitative and quantitative fit testing a bit later in the safety connection. Assigned protection factors can also be used to determine the maximum use concentration for respiratory protection. So what is maximum use concentration? It's the maximum concentration a respirator can be expected to protect a worker from. So the maximum concentration a respirator can be expected to protect a worker from. Let's look at an example here using toluene. Toluene has an O.Reg.833 occupational exposure limit OEL of 20 parts per million. Let's say we were using a half face piece air purifying respirator and we looked in the table, we would see our assigned protection factor of 10. To get the maximum use concentration, we would multiply that occupational exposure limit of 20 by our assigned protection factor of 10 to get a maximum use concentration of 200 ppm. If your workplace air concentration was greater than 200 ppm, then you would need to select respiratory protection that offers a higher level of protection, or more ideally, implement controls to reduce the air concentration. Let's say we were using a full face piece air purifying respirator. So we have our same agent, toluene, We have our same O.Reg.833 occupational exposure limit of 20 ppm. We did quantitative fit testing, so we have that assigned protection factor of 50. We multiply our OEL by our assigned protection factor to get a maximum use concentration of 1,000. However, you'll notice I've highlighted that in red here because we need to consider the immediately dangerous to life and health concentration. So if we looked at the NIOSH pocketbook, we would find the immediately dangerous to life and health concentration for toluene is 500 ppm. If we remember, we cannot use air purifying respirators above concentrations that are IDLH. So in this scenario, the maximum use concentration for the full face piece respirator is less than 500 ppm. So now that we've covered the types of respirators and assigned protection factors, let's start to look at the different types of filters and cartridges that are available to use with respirators. For particulate filters, we have N series or non-oil filters. These are protective against aerosols that are free of oil. An example might be wood dust. We also have R series filters. R series filters are resistant to oil aerosols. Example of oil aerosols might be from automotive oils, vegetable oils, lubricants. These are resistant to oil aerosols. These filters have a time use restriction, for example, to replace after 8 hours. And P series are oil proof. Keep in mind though that time use manufacturer restrictions can apply to these filters as well. We also have filtration efficiency of 95, or filtering 95% of particulates, 99 filters 99% of particulates, and 100 filters 99.97% of particulates. NIOSH has a good infographic shown here that outlines the respirator filter classes. It'll be available in our reference list if it's a resource you'd like to use. Next, we will cover filter changeout schedules. So be sure to establish filter changeout schedules for your particulate filters. This includes replacing the filters when they become damaged or dirty to prevent contamination based on breathing resistance. So particulate filters are made up of tightly woven fabric, which trap the particulates. This will start to create breathing resistance as the particulate loads on to the filter. If the resistance is too much, then it indicates it's a time to change out the filters. And also based on those manufacturers' recommendations, such as for P and R series filters. Next, we're going to cover chemical cartridges. Cartridges are filled with an adsorbent material, such as charcoal, which removes the vapors and gases as air passes through. There are different types of cartridges to use for different types of gases and vapors. Examples might be an organic vapor cartridge and an acid gas cartridge. Cartridges can also be combined with a filter to offer protection from gases, vapors, and particulates. A common example is an organic vapor and P100 combination cartridge filter. Color band system to define protection. There is a standard color coding system to define the type of protection that a cartridge provides. So for example, organic vapor cartridges have black labeling, and this is consistent across manufacturers. So a 3M organic vapor cartridge should have a black label, and a Honeywell organic vapor cartridge should also have a black label. This system helps identify cartridges, but you always want to be sure to check the label and the manufacturer's guide for the type of cartridge you are using to ensure it's correct. I'll highlight color banding a bit more on the next slide. We also encourage folks to reference the manufacturer's guides relating to selecting respirators, cartridges, and filters. Manufacturer's guides are a great resource for selecting the right respirator and cartridge for the chemical you want to provide protection against. 3M, for example, has a great respiratory selection guide to reference if you're using 3M respirators. There is the standard color coding system for chemical cartridges. You might be familiar with like P100 pancake filters, the pink filters or magenta filters. They're consistent across manufacturers, should be the magenta color regardless of the manufacturer. Ammonia, methylamine are green. I was mentioning organic vapor should have that green or that black label on the cartridge, Organic vapors having the black label on the cartridge regardless of manufacturer, and multi-contaminant or multi-gas should have the olive color label regardless of manufacturer. So next, let's take a look at cartridge changeout schedules. As the adsorbent material in cartridges becomes saturated, not all of the gas or vapor may be adsorbed, leading to potential for breathing in the chemical or breakthrough. A cartridge changeout schedule helps to prevent breakthrough, and there are a few resources you can use in developing cartridge changeout schedules. Some manufacturers have software that allow you to estimate breakthrough and when you should change a cartridge. They require information such as the chemical of concern, the anticipated average exposure, the exposure limit, the workload, and even the atmospheric conditions. So we did a hypothetical example using MSA's cartridge life expectancy calculator for ammonia, just so you could see what an application of a cartridge software might look like. And you can see here, the hypothetical breakthrough time is 4 hours and 30 minutes. You can also look for 3M, which has select and service life software for their respiratory protection. IRSST has SatRisk to calculate the service life of organic vapor cartridges. And MSA has their cartridge life expectancy calculator. You can also connect with your manufacturer to see if they have software available that you can use. Just make sure that you understand how to use the software and always follow the manufacturer's instructions for cartridge changeout schedules. Also consider the expiration date for your cartridges. Look at the cartridge's exterior packaging. For example, if you have a stock of cartridges in your storage room, this is very important because the cartridges would have an expiry date. You can also look for end of service life indicators. Some manufacturers have cartridges that have this, but not many. It would be something like a colorimetric indicator on the outside of the cartridge that indicates when to change it. So for example, a strip that turns from green to red, indicating it's time to change it. Connect with your manufacturer to determine if an appropriate cartridge with an end of life service indicator is available for your contaminant. And if you smell or taste a contaminant, or if irritation occurs, this might be an indication of breakthrough. You want to leave the area, report the incident, and investigate the situation. So now that we've covered some aspects of cartridges and filters, what types of cartridges and filters do you use in your workplace? Particulate only, chemical cartridge, combination? And maybe even throw in the chat what type of cartridge you use. Oh, lots of combinations so far. Maybe you use a P100 chemical cartridge. Maybe you use that OV cartridge. Combination of both. Yep, to capture both. That's awesome. A few more responses for particulate. I'll let a few more polls come in and then we'll close it. But that's good to know. Throw in the chat what type of cartridge you use. I bet you there's a few common ones in there. Awesome, thank you. Next, we're going to talk about use and care of respirators. So use and care of respirators includes being clean shaven to ensure that facial hair does not affect the seal of tight-fitting respirators. O.Reg. and O.Reg.833 and O.Reg.490 require this. CSA Z94.4-18 outlines this as well. The NIOSH and CDC have a great infographic, which you might have seen before, that outlines some facial hairstyles that may interfere with the seal of a respirator, and we'll take a look at that infographic on the next slide. A respirator must be inspected prior to any use. O.Reg.833 and O.Reg.490 have a requirement to provide training on the inspection of respiratory protection. CSA Z94.4-18 outlines conducting inspections as well. Inspections might include inspecting the condition of the various parts of the respirator, including the facepiece, the valves, the straps, the cartridges, even those end of service life indicators. And use of a respirator also includes conducting positive and negative pressure seal checks prior to each use of the respirator. This is a requirement under O.Reg.833 and O.Reg.490. CSA Z94.4-18 outlines this as well. And I'll show you a picture demonstrating user seal checks in the coming slides. The CDC and NIOSH also have this video available, which outlines proper donning and doffing techniques, as well as seal checks for respirators. And I will, the link will be included in the reference list as well. Care and use also includes following manufacturer's requirements for cleaning and sanitizing respiratory protection. This is a requirement under O.Reg.833 and O.Reg.490. Refer to manufacturer's guidance for cleaning and sanitizing. It might include cleaning with water and some type of specific detergent. And lastly, it's important to ensure that respirators are stored in a clean and sanitary location free of contamination. This might be in a locker away from the work area. Respirators stored in the work area, such as on a welding bench, are likely to become contaminated or damaged, which is why it's important to store in a clean and sanitary location. So next we'll look at the CDC and NIOSH infographic, highlighting the various facial hairstyles that may or may not affect the seal of a filtering facepiece respirator. So you can see here, we have a worker clean shaven, the sealing surface of the respirator. There's no facial hair that interferes with that sealing surface. We have worker here with the soul patch style. Sealing surface is not interfered. If we go over to a full beard, for example, we can definitely see that the sealing surface of the respirator would be affected by the full beard. These are examples. Whatever the hairstyle is, it's important to ensure that facial hair does not contact that sealing surface of the respirator. Next, we'll touch on seal checks. A negative pressure seal check involves covering the respirator's cartridge or filter with the palm of your hands and inhaling. You should feel a slight collapse of the respirator while you hold your breath in. You should not feel any inward leaks. This would indicate an ineffective seal. Sorry, if you don't feel any inward leaks, this would indicate an effective seal. A positive pressure seal check involves covering the exhalation valve of the respirator with the palm of your hand and blowing out. The respirator should puff out slightly while you blow out for about 5 seconds. If you don't notice any outward leaking, this would indicate an effective seal. And respirators are required to be stored in a clean area to ensure that they do not become contaminated. Follow manufacturer's recommendations for storage. Some storage options might include storing in a clean plastic tote or in a sealable bag or other closable bag, such as a drawstring bag or a manufacturer provided bag. Next, let's look at training requirements. There are some regulatory requirements under O.Reg.833 and O.Reg.490, which require training and instruction on limitations of the respirator. For example, use of air purifying respirators in environments that have sufficient oxygen and are not immediately dangerous to life and health. Training and instruction on inspection and maintenance of the respirator, including end of service life indicators, changeout schedules for respirator cartridges, canisters, or filters. Training instruction on proper fitting of the respirator, for example, being fit tested, being clean shaven, and conducting those user seal checks, as well as cleaning and disinfecting the respirator. Training should be completed by someone competent, such as because of knowledge, training, and experience in the various aspects of respiratory protection. CSA Z94.4-18 provides additional content on training and provides a training matrix that summarizes the training requirements for a respiratory protection program. Training matrix components include respirator selection, respirator user screening and medical assessment, and we'll talk more on user screening in a few slides, fit testing, instruction, care and practical use, such as donning, doffing, seal checks, limitations, and repair and maintenance. The CSA Z94.4-18 training matrix may be helpful in developing the training requirements required under your respiratory protection program. Jessica introduced us to qualitative and quantitative fit testing. Tight-fitting respirators are required to be fit tested. O.Reg.833 and O.Reg.490 require respirators to be fit tested following qualitative or quantitative fit test methods. As Jessica outlined, fit tests are conducted in accordance with Annex B or C of CSA Z94.4-18, which outlines the methods for qualitative and quantitative fit testing. For the types of fit testing, we'll start with quantitative fit testing. Quantitative fit testing typically involves using an instrument to assess the amount of leakage into the respirator. The concentration of particles inside the respirator and the concentration of particles outside the respirator are determined using a particle counting instrument. We can see here an example of a TSI porta count. The blue line in the picture here would be used to measure the ambient air particle concentration in the room, and the clear line would be connected to a probe and put inside the respirator to measure the particles inside the respirator. The respirator is equipped with P100 filters during the fit test, which prevents particles from getting through, so any particles detected inside the respirator are assumed to have entered through a leak. The instrument provides a fit factor based on the concentration of particles outside versus inside the respirators. Workers perform different exercises which challenge the respirator, and the instrument provides a pass-fail result and an overall fit factor for the test. A pass would mean that a specified fit factor was achieved. If we look at qualitative fit testing relies on an individual's sensory response. So it relies on an individual's sensory response to an agent such as a bitter or sweet aerosol. So for example, qualitative fit test involves performing a sensitivity test to determine if the individual can detect the bitter aerosol. If they can, then the fit test proceeds with the user donning the respirator, performing their seal checks, and a hood is put over their head, and aerosol administered into the hood. If the user detects the bitter taste during an exercise, then this indicates an ineffective seal and the test fails. If the user does not detect the bitter aerosol, then the fit test passes. CSA Z94.4-18 outlines that a qualitative fit test is not to be used for SCBA or multifunctional SCBA airline applications. CSA Z94.4-18 also outlines a requirement for fit testing and for being clean shaven. CSA Z94.4-18 outlines that a fit test shall be carried out after the completion of user screening, and we'll cover user screening in just a couple slides, after or during initial training. So consider a scenario where you conduct fit testing right after you've conducted a training session, prior to initial use of a tight-fitting respirator, when a user's physical condition changes, for example, significant weight loss or gain, changes to facial features, maybe getting dentures, when there is a change in respirator. So your fit test is good for the make, model, and size of respirator that you were fit tested for. If you change the make, model, or size of respirator, then you need a new fit test. When a user experiences discomfort or inability to successfully complete those seal checks, and when there's a change in PPE. So the fit test is done with the PPE that you're going to wear when you're wearing the respirator. If you change the PPE that you're wearing with the respirator, then you need a new fit test. And CSA outlines at least every 2 years or more frequently based on other conditions. Okay, and the fit test is documented on a fit test record. CSA Z94.4-18 has additional content on user screening, such as completing a user screening form prior to fit testing that confirms the worker is free from any condition that would prevent them from being fit tested or using a respirator. A screening form for respirator users can assist in identifying general conditions that could necessitate an evaluation by a healthcare professional. CSA Z94.4-18 has a sample respirator user screening form that you might find useful. We have provided a snip of our WSPS user screening form that we use prior to conducting fit test, which was developed based on the CSA standard. This information must be treated as confidential. In our WSPS user screening form, we ask workers to select a yes or no answer to these 4 questions. If any answer provided is yes, then this indicates that a further evaluation by a healthcare professional is required. If either the employee or the administrator have concerns, you seek that opinion from the healthcare provider. The healthcare provider provides a written opinion back to indicate if the worker meets medical requirements. meets medical requirements with limitations, or does not meet medical requirements to use the selected respirator. That covers user screening and health surveillance. Next, we're going to look at program evaluation and record keeping. CSA Z94.4-18 outlines to review regularly, at least once a year, more often if processes change. This helps to ensure the program is being managed effectively and that respirator users are being adequately protected. The RPP should also be reviewed with your Joint Health and Safety Committee as a best practice. If the respiratory protection relates to a designated substance, then reviewing with the committee may be a requirement as part of your control program review. Okay, and lastly here we have record keeping. CSA Z94.4-18 outlines record keeping requirements for a respiratory protection program. Record keeping should include documentation on individuals fulfilling the roles and responsibilities of the program, any hazard assessments that you conduct, selection of the respirator, so respirator selection forms, training records, respirator facial fit, so your fit test records, cleaning, maintenance, and storage of respirators, health surveillance of respirator users, so your user screening forms, as well as program evaluation records. And these records, following CSA Z94.4-18, should be maintained for the duration of employment of the person trained or a minimum of 10 years. So that wraps up the content portion of our safety connection. We have some additional resources here that will be included in the reference list sent out to you. WSPS can also help assist with your respiratory protection needs, including training and consulting services such as fit testing, conducting air exposure assessments, and respiratory protection program development. These are our references here for our safety connection. Some of them will be provided to you in the reference list. And lastly, we just want to thank you for listening and participating. We're right at 12 o'clock, but Jess and I will happily take any questions that you might have in the next few minutes here. So thank you all. Zishan, does CSA Z94 cover escape records in regard to care use? I'm not sure on that. You'd have to look at the standard itself. Jess, are you aware of escape respirators being covered?
No, unfortunately, I haven't had that experience quite yet.
Yeah, I haven't had that ask, but if you can access the CSA Z94.4-18 online for free, as Jess was saying, so you can take a look there. Thank you all for the Pat, hi. Thank you all for the thanks. There's no other questions. I think we'll just wrap up here in a second. Thanks.
And if you do have, thank you, Kirby,
yeah.
and everyone
yeah.
else.
Yeah, go ahead, Jess.
If you do have any further questions, that you think about later on, certainly there will be that follow-up email with our contact information and those references and resources that Maddie had mentioned. So certainly please reach out to us and we'll be able to hopefully find that information for you. And if not, we do have an extensive team of occupational hygienists that we can reach out to as well with some wonderful experiences. So we should be able to get the information you need to you.
Awesome. Thank you.